Alright, a little bit revision on what we learned yesterday. Okay, yesterday we learned a rule called chain rule. Chain rule is help us to do some differentiation, especially with some composite function. If we put one function into another function and we don't want to do expansion, we want to differentiate that easily, we can use chain rule. So the key idea for chain rule is introduce a new variable and use dy du times du dx to differentiate. Okay, to differentiate. So like the example we do is a quadratic to the power of 3. Like we put a quadratic into a cubic function and we don't want to do expansion. So we can just introduce a variable u, make u equals to 3x squared plus 1. So I have made two functions now. One function is y equals to u to the power of 3 and the other function is u equals to 3x squared plus 1. Both functions are easily differentiated, can be easily differentiated. So I can differentiate both and times them together. That's the chain rule. So we have also 18x times 3x squared plus 1 to the power of 2. And then we learn two results. Like those two results exactly come from chain rule. But those two results is, I want you to remember that. I want you to remember that, and we can directly apply it when we do the questions, not like doing change of variables every time. So the two result I have is, if you have something right as f of gx, just exactly looks like that, the derivative of f of gx, we will have derive the inside g dash x, derive the outer function which is f dash, and then we still put gx into the original function. So it's f dash of gx. Well, this one is very limited use. I show you example 3 how we can use it. We either exactly looks like that. I don't know what's the function of fx. I don't know what's the actual numbers of gx. I can use this rule. Or I can use this rule if I have f of 3x squared plus 1. So still I have one function unknown. Like I don't know what's the rule for f, but I know part of gx. Like I know the inner function. I can still use this formula, which is this derive the inside becomes 6x times derive outer, we just represent as f dash and then keep the inside. So f dash of 3x squared plus 1. When do we use this one is when one or two or both of the rules is unclear. Okay, it's unclear. We don't know what the exact rule is. It's just represented by a symbol f or g. And then when we see this type, we can apply this rule here. Okay, we can apply this rule here. The second one is easy. Second one is something to the power of something. Okay, something to the power of something. So what we should do is 3 steps. First of all, we times n, which is the power. Second step is we derive the inner function, like something to the power of n, we derive the something. And then times the same equation, but we minus the power by 1. Okay, we subtract the power by 1. So 3 component, n, reduce power by 1, and derive the inside function. That's with something to the power of n. You can see this form quite clear. And I ask you to try some examples here. Okay, try some examples here. So we want to find the derivative of the following function. Okay, we want to find the derivative of the following function. For the first one, you can see that's something to the power of 2. Okay, something to the power of 2. Well, you can do 2 things. You can either expand. Like square is easy to expand. I can expand it. I can say this equals to 4 without using the chain rule. I can say that's 4 minus 2ab, that's 20 square root x, that's x to the power of a half, and then plus 25x. Just expand it. Okay, we can expand it. And then I can say d dx of 2 minus 5 root x squared equals to negative 10 x to the power of minus a half plus 25. I can rearrange it a little bit. That's 25 minus 10 over square root x. I can have this result. Okay, I can expand it, or I can use chain rule. D dx of 2 minus 5 root x to the power of 2. That equals to, first thing is drag the power down, we times the power. Secondly, we derive the inside, the 2 minus 5 root x. 2 become just 0, and minus 5 times x, square root x is x to the power of a half. So it's a half times x to the power of negative a half. Okay, bring the half down and subtract the power by 1. And the third step is reduce the whole function power by 1. So 2 reduced by 1 is just 1, so to the power of 1. I can just do some simplifications. This 2 and this half can get cancelled. What I have is a minus 5 over square root x, bracket 2 minus 5 root x. We can have that. And I can expand it. That's minus 10 over root x plus 25. 5 and 5 become 25, and the root x and 1 over root x get cancelled. We still have the same result. Okay, we still have the same result. But probably for this one, it's easier to expand first and then derive, rather than use chain rule and then expand. But like they exactly get the same answer. Okay, exactly get the same answer. Okay, that's the first one. Any questions? No? Okay, for the second one, a lot of you ask me like how I can use chain rule. Well, not all the questions can use chain rule. You need to find your own way, like decide which method you're trying to differentiate. When we learn quotient rule, this one I can show you how to use quotient rule to derive. Okay, some function divide by some function. But like before we learn this, what we can do is rearrange it. That's 2 over x squared plus root x is x to the power of a half over x squared. And that is 2x to the power of minus 2 plus x to the power of negative 3 over 2. Then the dx of this function, that equals to minus 4x to the power of minus 3 minus 3 over 2 times x to the power of minus 5 over 2. Well, if you don't like negative indices, I can make it into the fraction form. Okay, I can make to the 1 over the reciprocal form. Well, not necessarily always change the power into positive, but if you have something like x to the power of negative a half, it's better to make it 1 over root x. Okay, it's better to make it 1 over root x because it's easy for you to evaluate. Okay, it's easy for you to evaluate. You can't evaluate, well, for example, I ask you to evaluate x to the power of negative 5 over 2. You still need to make into the reciprocal form and then substitute numbers in, rather than just keeping that form. So for evaluation, it's better to change it into positive power. Okay, that's B. Okay, that's B. Well, a lot of you trying to think very hard how to use chain rule, but you can't really use chain rule here. You can use quotient rule for this one. We'll come back to this one after we learn quotient rule. You can try how to use quotient rule after tomorrow lesson. Okay, for the next one. Well, next one is easy to use chain rule because we always want to make things into power function. I don't like to see anything in third form or reciprocal form. Always make a negative power or fractional power. So after I change this to this form, d dx of cube root x plus x squared will equals to, first thing is we drag the power down. Second thing is we derive the bracket, like the inner function is 1 plus 2x. The third thing I will times is the original function, but reduce the power by 1. So a third minus 1 is minus 2/3. So what I can do is 1 plus 2x over 3 times x plus x squared to the power of 2 over 3. That's for part C. Well, for D is even straightforward. It's already give you into the power form. First thing, we drag the power down, make it -1/2. Second, we derive inside. The inside becomes 2x. And the third thing we'll do is reduce the power by 1, which is -3 over 2. Okay, -3 over 2. And that equals to, that's a minus x on top over 1 plus x squared to the power of 3 over 2. I shouldn't have much problem for those 4 questions. It's just ask you to use chain rule or any other method to differentiate. Okay, to differentiate. But the thing is, don't forget the notation. You can't directly say this function equals to the derivative. This function doesn't equals to the derivative. It's differentiate d dx of that function equals to the gradient. Okay, so you need to remember the notation. Yes?
Right, f dash x.
Do you have f in the function? Is there a name for this function? No. If you have fx equals to something, you can say f dash x, or y equals to something, you can say dy dx. But there's just a pure expression, there's no function. So it's d dx of that expression equals to something. Okay? All right, example 2. Given that dy dx equals to a over x squared plus 1, and that when x equals to 1, dy dx equals to 3, and y equals to 3. So what you can see here, that's 2 pieces of information. First of all, 1, 3 is on y-x graph. Okay, on the original graph. 1, 3 is on the y-x graph. And also, I can find when x equals to 1, dy dx equals to 3. So dy dx equals to 3 when x equals to 1. Which I will have a equals to 2. Which I will have a equals to 2. So therefore, dy dx will equals to 2 over x squared plus 1. So first of all, you want to complete what's the derivative function. Like you want to see what is the derivative function. So that is 2 over x squared plus 1. Then I will find the function y. So y equals to integral 2x to the power of minus 2 plus 1 dx. All right, everyone, how to antidiff? Do you remember how to antidiff? Yes? Yes, so we add something to the power that's minus 1, and we divide by minus 1. Thank you. And then how about the 1? 1 becomes x. What else I need? Plus c. Okay, so y equals to minus 2 over x plus c. Just rearrange that a little bit. And what we will have is 1, 3 is on this function. So 3 equals to minus 2 plus 1 plus c, which I get c equals to 4. Which I get c equals to 4. So y equals to minus 2 over x plus 4. So when x equals to 2, y equals to minus 1 plus 2 plus 4. y equals to 5. Y equals to 5. So when x equals to 2, y equals to 5. That's your final answer. Okay, because we have talked about antidiff here. Okay, so what we have done to when we differentiate x to the power of n, what we have done is we times n and we reduce n by 1. Now what we should do is we add by 1 and then we divide the larger power. Now I want to extend it a little bit. I don't think this is in year 11, but I really want to extend this a little bit. Let's think about, like gx to the power of n is n times g dash x times gx n minus 1, right? If I change my gx, where I should write it? I write it on the top. If I have fx equals to ax plus b to the power of n, what's the derivative? What's the derivative here? Just in terms of a, b, n. What's your gx here? Yeah, ax plus b. So we still do the normal steps. So what's the first step? N. And what else? Derivative of the inside? A. And what's next step? Yep, ax plus b to the power of n minus 1. Okay, that's the derivative. Okay, still 3 steps, but like I restrict the gx become a linear. Okay, I restrict the gx become a linear. So what's the 3 step is times by n, times by the coefficient of the linear, right? The a, like the gradient of the linear, because when we derive the linear, we have the gradient. And then the third step is still minus n by 1. So now let's think about the anti-differentiation. Anti-differentiation. Of ax plus b to the power of n dx. What I will have for that? Trying to think similarly, what's the 3 steps we have done? Times by n, times by a, and reduce the power by 1. That's the 3 steps. So what's the first step you should do when we antidiff it? Plus 1 first. Because the power needs to go back to the original power. What's the next step? Divide by n plus 1. What else I should divide? We times a originally, what we should divide by a. And then plus c, don't forget the plus c. Okay, 3 steps. So we still have 3 steps when we do antidiff. We times by n, we times by a, and we minus the power by 1. So going backwards is because you times by the power first and then minus 1. So now when you go backwards, you need to add by 1 first and then divide by the larger power, like divide by n minus 1. The one more step you have is you need to divide by a. Because when you differentiate, you times that by a. Okay, it needs to divide by a. So that's the antidiff of a linear to the power of n. Okay, a linear to the power of n. That's quite, I don't think is in this test, but I think it's really good for you to remember this rule because you will learn it anyway in year 12. So it's good to talk about it here because it's just chain rule. Why? It's because of chain rule. When we do chain rule, we have that result. So when we go backwards, we have similar result. Why I restricted the gx into linear? Because when we differentiate linear, we only got a constant. When we do antidiff, we can times or divide constant easily. But if, say, gx is x squared, you can't divide by 2x. Okay, when you do antidiff, you can't divide by x or times x with no reason. You can only times or divide a constant. So that's why I restrict the gx into x plus b. the derivative of inside is just a constant. I can always divide constant easily. Okay, that's the reason why I only have the linear to the power of n form. Okay, that's the only formula you need to remember. Like the last formula needs to remember from year 11 for polynomial differentiation and anti-differentiation. When you learn that, everything's done for polynomial. So next year you will learn circular function, exponential, and logarithms derivative, and that's it. Okay, so 3 more things to learn. Okay, back to example 3. I'll just show you an example maybe. We're just trying to antidiff 5 over 2x minus 1 to the power of minus 3. Let's try to antidiff that. What's the first step you need to do? To the power of what? Yep, to the power of negative 2. And then divided by negative 2 times by 5 over 2. Divide by a. A is the coefficient of the x, so which is 5 over 2. And then what I should have? Plus c. Good. Antidiff, always remember the plus c. So what I have here is 1 over minus 1, because the denominator is a minus. Minus 1, 5 times 5 over 2x minus 1 to the power of 2 plus c. Okay, that's the antidiff. Very easy, but we just remember there's one more step, is divide by coefficient of a. That's a lot of year 12 always forget. Okay, always forget. Very, very important rule here. Okay, last question. Last question is, a lot of you can't understand what the question represents. Can't set up a equation for it. So find the equation of the curve which passes through the point negative 1, 2. Okay, negative 1, 2. So this is a point. This is a point on the curve. Okay, this is a point on the curve, and has the property that for each point x, y on the curve. Okay, so we represent all the points on the curve by x, y. The gradient, okay, the gradient is what? Gradient is dy dx, right? Gradient is dy dx. So the gradient equals to the square of the distance between the point and the y-axis. Well, let's have a think. We have a point x, y here. This point, the distance between this point and the y-axis is this line. Well, that's the distance between any point and the y-axis. How I can represent this length? X, right? That's just x. Well, the x value is the distance from the y-axis. So what dy dx equals to? Dy dx equals to the square of the distance from the y-axis. Well, for any point, the distance from y-axis is x, and the square of that distance is x squared. Okay, it's x squared. So if x is 4, then the distance squared, it will be 16. So dy dx equals to x squared. Then after that, after I set up that, it's very easy to find the equation of y. Y just equals to the antidiff of x squared. That just equals to the antidiff of x squared. So what I have is y equals to a third times x to the power of 3. So we increase the power by 1, becomes 3, and then we need to divide by 3. And you have the plus c. So you have the plus c. I want to work out the C value. I know a point -1, 2 on it. So 2 equals to -1/3 plus C. So C equals to 7/3. So y equals to 1/3 x cubed plus 7/3. Okay, so the only hard step for this question is set up this differential equation, the dy dx equals to something. So you need to express the word into math notation. After you do that, it's just a normal antidiff question. It's just a normal antidiff question. Okay, I will stop here, and you can either do some practice from the textbook. Okay, that's what you can do for the rest of time. Or you can have a look at the 2 rules giving you below. Okay, You can have a think about it. Tomorrow I'll go through those 2 rules. There's not much reason for it. It's just a rule and you need to remember it. That's it for today.